Hey class, good afternoon. I know that some of you, because of the internet outage, weren't able to go through the lesson, so I'm just gonna hop on here and quickly go through the lesson with you. Just a note, this should have been, I apologize for that, that should have been A, this should have been A as well. So that's the homework up there at the top. We're just going to be going through and investigating and verifying properties of quadrilaterals. This is just stuff that you could have already done by yourself. I just want to take it up with you. By the end of this lesson, you'll know key properties pertaining to the line and midpoints of a parallelogram. You'll know how to determine the length of sides inside a parallelogram, and you'll know how to verify properties of parallelograms as well as quadrilaterals. Okay. So in a parallelogram, the one thing to remember is that diagonal. So if you take the line from the vertices diagonal to each other and you cross them, they both bisect each other in the middle. These are usually at 90-degree angles if it is a 90-degree. That's just something important to know, that they do bisect each other, the two diagonals in a parallelogram. Right? The next thing that's important to know is that if you take the midpoints of adjacent sides of any quadrilateral, so this is a quadrilateral because if you look at it, it's all four sides, right? If you take the midpoints, so if you take the midpoint from A to B here, it's going to be F, right? From D to C here, it's going to be H, and then G and I. If you take the midpoints of all those lines and you draw them together, this is actually going to be a parallelogram as well. Okay? I wouldn't worry too much about this. I had told the in-class people not to worry too much about it as well. Just read over the rules for that. So we're going to get to the nitty-gritty of this, and the first thing is that we're going to be verifying properties of quadrilaterals. So verifying properties just means that prove that this is true. So the first question asks us prove or verify that quadrilateral EFG, so that's the diamond in the middle, formed by joining the midpoints of adjacent sides of quadrilateral ABCD is a parallelogram. So what it's basically asking us to do is prove that this in the middle here is a parallelogram. And we know that it is because we know that from the rule up here, right, that joining midpoints of adjacent sides of any quadrilateral forms a parallelogram. So we know that to be true. We just want to prove it, right? So let's go ahead. If we want to prove that this is a parallelogram, what we need to do is find that both sides, right, are parallel to each other. So there's two sides, opposite sides, which are parallel to each other. Right? So in order to do that, we're going to show that the slope of the opposite sides of EFG are equal. So I'm just going to write that in. Sorry, guys. Okay? And so what we're going to do now is, in order to prove that they're the same, we've got to, one, find the midpoints, because we need to find what points E, F, G, and H are, because we don't know what they are. We just know where they are on the graph, right? And then we're going to find step 2, which is going to be find the slope of each of those sides. So I'm going to do finding the midpoints with you first, and then we'll move on and find the slopes together. So I'm just going to start here. So I'm just going to say step 1. Find all the midpoints of each line in ABCD. right? So let's go find what E is. So E, the X and Y coordinates are the midpoint between, if you look at your triangle here, E is the midpoint between A and B, right? So we're going to go, okay, what's the midpoint formula, which we know is x2 plus x1 divided by 2, y2 plus y1 divided by 2, right? If we go look at our formula, we know that we'll label the 4 as x2, y2, right? We'll label this as x1, y1. So I'm going to go ahead and find that this is going to be negative 4 plus 2 divided by 2, which is going to give me negative 2 over 2, which is just 1. Oh, sorry, negative 1. Right, and then on the flip side here, we have 2 plus negative 5 divided by 2. 2 minus negative 5 is, or 2 plus negative 5 is negative 3 over 2, so this is about 1.5. Okay, so that is my side E, or my coordinates for E. Okay, and then we're going to go ahead and find the coordinates for F. So I know that F right here is B to C. That's what I'm looking for. So maybe I'll keep the B as x1, y1, and we'll make this x2, y2. Right? So now I have 7 plus 2 divided by 2, negative 3 plus negative 5 divided by 2. Right? 7 plus 2 is going to give me 9. Divided by 2, negative 3 plus negative 5 is going to give me negative 8. Divided by 2. Right, so I'm left with 4.5. Negative 4 is my F point. Now we're going to go ahead and find our G point. So G here is between D and C. Right, so I'm going to find what the midpoint between D and C are. So G, xy is equal to x1 plus x2 divided by 2. Right, I'm not going to write out the entire formula, but you get the idea. And so for G, we have, let's label our C, and we'll change this to x1, y1 now, and we'll change this to x2, y2. Right, so let's do 5 plus 7. Right, 5. Oh, sorry. 1 plus 7, not 5 plus 7. Because you're just taking the two x's. Divided by 2. Oh, man. 1 plus 7 divided by 2. And then our y's, which are 5 and negative 3. So 5 plus negative 3 over 2. Right? So then I'm left with the 1 plus 7 is going to give me 8 divided by 2. 5 plus negative 3 is going to give me 2 as well, divided by 2. So I'm just going to reduce this. 8 divided by 2 is just 4 and 2. So that's point G. I'm just going to go and find all my midpoints so that I have something to work with for their slopes. G. Right, and then last but not least, we're going to look for H. So H goes from here to here. So it's between A and D. So let's find the midpoint between A and D. H. So maybe I'll make this one x1, y1. Right? So let's do this as x2 is 1 minus negative 4 over 5 minus 2 equals 1 minus negative 4 is just 1 plus 4, which is 5. 5 minus 2 is going to give me 3, right? So oops, sorry, I wanted to find the midpoint. So 1 is going to be, what did I write? And the other one was just going to be 5 plus 2 divided by 2, right? So it's going to be negative 3 over 2 and 7 divided by 2. Negative 3 divided by 2, I'm just going to put as a decimal. You can leave it as a fraction. I'm just putting it in. 7 divided by 2 is going to be 3.5. It just makes it easier to graph and work with those numbers after. So now that I found all of my midpoints, I'm actually going to go in, use these midpoints to find the slope, right? So the step 2 is going to be use midpoints, find the slope. So just as a refresher, the formula for slope is m equals y2 minus y1 over x2 minus x1. Right? So the first thing we're going to do is let's find the equation for e to h. Let's find the slope for that. So slope of e to h, right? You're going to take the coordinates for e, which are negative 1 and 1.5, negative 1, 1.5, and for h, which were negative 1.5 and 3.5, right? And you're just going to go put them into the equation. So for e, h, I ended up doing negative 1.5 minus, so I made this x2, x1, y2, y1 minus negative 1 over 3.5 minus 1.5, right? If I went and did that math, negative 1.5 minus negative 1 is going to give me, I just need to make sure that I have the right. So E was negative 1, 1.5. H is negative 1.5 and 3.5. Yep. So negative 1.5 minus negative 1, right, is going to give me 0.5. Oops. Sorry, y'all. I figured out what I did wrong. You need to make sure that the y's are at the top. Oh, boy. So y2 is 3.5 minus 1.5 divided by negative 1.5 minus negative 1, right? So at the top, we're left with 3.5 minus 1.5 is going to give us just 5. Negative 1.5 plus 1 is going to give me 0.5, which I'm going to be left, or negative 0.5, which I'll be left with negative 10. 5 divided by negative 0.5 is 10. So that's the slope for EH. Okay, so if I want to find out if that is parallel to our line over here of GF, I need to find out what the slope of GF is, or FG is, right? So let's go find the slope of FG. Again, F for us was, I'm going to go find the value again, 4.5 and negative 4. And then for us, the other one was G, and the points for G were 4 and 2. And I think for this one, I ended up making my Y2 values and X2 values were my FG. Oh, we just got a 2 and this should actually be 1. Sorry if you're watching this after and realizing that I made the mistake. 4 and 1, right? So I made this one my x1, y1, x2, y2, right? Doesn't matter which way you do it. So then I have y2, which is negative 4 minus 1, x2, which was 4.5, minus x1, which was 4, right? And that's going to give me my slope. So slope is equal to negative 4 minus 1. It's just going to be negative 5. 4.5 minus 4 is just going to be 0.5. So negative 5 divided by 0.5 is going to give me negative 10. So those two are the same. So those two are parallel to each other. Now we want to go ahead and compare our other lines. So we want to compare HG, right, to E and F. So let's go figure out for HG what our points are for H. So slope of HG, right, is going to equal y2 minus y1. So I'm just going to go, I like to put in my points actually right on the graph because it's easier to work with that way, right? So I have 4, 1, and for H, I have 1.5, 3.5. And remember that this is a negative. All right, so let's go use those points. So I'm going to label my H as the 1 and then my G as the 2. So I have 1 minus 3.5 divided by 4 minus negative 1.5, right? So then I'm left with 1 minus 3.5, which is going to be our two values over there for the y2, right? It's going to give me 2.5 divided by 5 minus negative 1.5 is just the same as saying, 4 minus negative 1.5 is the same as saying 4 plus 1.5, which is going to give me 5.5. And if I do that math, I'm left with negative 0.45. So that's the slope of HG. Right, now that I have the slope of HG, I want to compare it to the slope of G and F. Or sorry, not G and F. HG, I want to compare it to the opposite side, which is going to be EF, right? So let's go ahead, find that. Slope EF is equal to y2 minus y1. So for my y, I did the y2 minus y1, I did negative 4 minus negative 1.5 divided by 4.5 minus negative 1. And I'm just taking those coordinates. And I'm left with negative 2.5 divided by 5.5, which again, when I do the math, EF is equal to 0.45. So notice how the slopes here are the same and the slopes here are the same. This means that this is a parallelogram. And therefore, as opposite sides are parallel to one another. Cool. And we know that they're parallel because the slopes are the same. Okay. So just going to move on to properties of a rhombus. The thing to know about a rhombus is that for a rhombus, remember all sides are equal to each other, right? So if I want to find out and want to verify that something is a rhombus, then what I'm actually going to do is go ahead, find the distance of all sides, right? Find the length of all 4 of the sides, and then compare them to each other. So I also wanted to make a correction here. This should have been negative 1. It changes the shape, so just go ahead and make sure you put that in. So side P is going to go to 3 and 3, so I'm just going to put P, and like I like to write my coordinates in. Side Q is going to be at 0 and 1. So Q is at 0 and 1. Side R is going to be a 3 and negative 1. So right here. Right, and then the last one is 6 plus 6 and 1, which is going to be right here. So side S is 6, 1. And I'm just going to go ahead and fill that in so that I have my rhombus. Okay. So now what I'm going to do is I'm just going to find all the sides. So let's find the distance for QP, right? Just so you remember, the formula for distance is square root x2 plus x2 minus x1 squared plus y2 minus y1 squared, all under the square root sign. Right, so let's go find our points for Q. Our points for Q were 0, 1. Our points for P were 3 and 3. So what I'm going to do is I'm going to make this x1, y1, x2, y2, right, and go plug in our things here. So x2 is 3 minus 0 squared plus y2 was 3 minus 1 squared. Square root everything. 3 minus 0 is just going to be 3 squared plus 3 minus 1 is just going to be 2 squared. 9 plus 4 square root of 9 plus 4, we're just going to make sure we do the fraction inside, or the adding, is going to be 13. So that means the distance of QP is going to be root 13. You can either leave it as root 13, which is the most accurate answer, or you can square root it. Either one is fine. But because you're just comparing the distances here, you can just leave it as square root 13. You're not really doing anything beyond that. Okay, so then we're going to find the distance between R and S. So let's go ahead, find what our R and S value were again. R is going to be 3 and negative 1. S is going to be 6 and 1. Right, so again, square root x minus, so let's make this x2, y2, x1, y1. So this is going to be x2 minus x1 squared plus y2 minus y1 squared. Right. So then I'm left with 6 minus 3, which is going to be 3 squared plus 1 minus negative 1 is going to be 2. I'm just going to do my math. 9 plus 4 equals square root 13. That means that the distance between R and S is square root 13. Again, you can go ahead and simplify this. I'm just leaving it like this for now. Notice how they're the same. Let's keep going. So now we found PQ. We found RS. Now let's go and find QR, right? So let's go here and say the distance between QR is going to be, let's find out what our Q value is, 0 and 1. Our R value is 3 minus minus 1, right? Square root. Let's make the bottom one our x2. So 3 minus 0, x2, y1, y2, x1, y1. Negative 1 minus 1 squared, right? So dqr is equal to 3 squared. Negative 1 minus 1 is going to be negative 2 squared. dqr is equal to 9 plus 4 square root. D is equal to square root of 13. Last one, and I know this is a little tedious, but we do need to prove that the entire thing has equal sides, so we need to find the last side. So we've found QP, right? We found RS. We found this one, so now we just need to find P and S. So distance between P and S is going to be We'll make this x1, y1, x2, y2, right? So square root 6 minus 3 plus 1 minus 3 squared, squared, square root equals 9, right? And the reason that is 6 minus 3 is 3. And I'll just go through this. You can skip the step. 1 minus 3 is 2, or negative 2 squared equals 9 plus 4 equals square root 13. So your therefore statement for this would be, therefore, since all sides have the same length, the shape is a rhombus. And that's all. And that's the end of the lesson. So if you have any questions, feel free to ask. I'll post the solutions on D2L as well. Thank you. Tomorrow you have your first test. We're just going to have the entire period to write it. You are allowed to use your notes. Just come ready for it. If you need extra help, I will be in the math office. I just have a meeting until 11:30, and then I'll be in the math office or in the classroom after that, okay? See ya.